Okay, guys, so here's G2, and hang in there. We're going to be doing applications of this stuff soon. So we are going to find the second derivative at a point. I say here find the indicated slope. Let me change it to derivative. Yeah, because in certain contexts, the second derivative can be thought of as a slope, but in other contexts, it just gives completely different information. So yeah, let me just say derivative. And it is coming. It's in the pipeline. You know how to apply these skills within an application within a problem. So what this is asking for right here is the second derivative at a certain point. Okay, and yeah. So what they're asking for here is they're asking for y double prime at the point -2, 1. And these are the x and y coordinates, so we're going to be plugging those in. So it's going to be just like the last phase, except, yeah, we're going to be plugging in for x and y. So, all right, so the derivative of this is -2y prime minus 2x. Then you're going to solve for y prime. So this is, so y prime is equal to 2x over -2y. So y prime is x over -y. And then I'm going to take the derivative again. And I need quotient rule. All right, so going over here, so y double prime. And I need a y prime after a y. A y. So I need a y prime after a y derivative. So the derivative of x is 1 minus x. Derivative of -y is -1 y prime all over -y squared. Okay. I'm trying to think how we should do this. Yeah, I guess. All right, let me just plug. Yeah, I guess let me just plug this in for y prime, or you could get a number for this now, or you could plug -2, 1 in here now, and then plug that in for y prime. It's totally up to you guys, okay? Yeah, so actually maybe you'll like that better. I didn't do this last year, but let's try this. Okay, so no, let me not do that. All right, let me just do this. So so we've got that y double prime is -y plus x, and then this is just that's just y squared. Now in for y prime, I could put that x over -y. Okay, then at -2, 1, y double prime is. So I'm plugging these in for the x and the y. So that's where y is. I got an x. I mean, you don't have to do the blanks like I do, guys, but it does help with like negatives and stuff. Okay, so this was a y, so that's a 1. This was an x, so -2. This was an x, so -2. This was a y, so 1. This is a y, so 1. And we like that. So, so we get that at negative 2, 1, y double prime equals, all right, that's negative 1. What does this end up being? This ends up being 4, right? Because that's positive 2. So negative 1 plus negative 4 is negative 5. I think I'm right. Let me double check. All right, so that's positive 2 times negative 2 is a negative 4. So that's negative 4, negative 1. Yeah. Okay, so now let's do this one. So they're asking for this, which means, yeah, so this means they want y double prime at negative 1, negative 3. And the Leibniz notation is telling us that we need to do that. Okay, I'm going to need product rule here. So this is negative y. So 1 equals 0. Okay, so I use product rule on this. Like I kind of thought of the product rule of that, and then I distributed the negative. So that's a way of thinking of it. All right, let me find, now I got to solve for y prime. So negative xy prime equals y minus 1. X. Okay, and now we need, now, okay, so here's another way of doing it, guys. This is what I was toying with the one above. Maybe if you're doing a problem like this, like here's another idea. At this point, we could find y prime at here. So, all right, so then at negative 1, negative 3, y prime equals, what is this? This is just negative 4. So instead of, so for this problem, instead of plugging in the first derivative in terms of x and y, and then plugging in my point, when I see the y prime, I could just put a negative 4. So that's another way. All right, so now I'm going to use quotient rule on this. Let me kind of section that. This is sort of like a little aside. That's kind of a little aside there that I'm going to hold on to for later. So now I need quotient rule. So y double prime is the derivative of the top is y prime. Here's the bottom. Okay. Yeah, so now I don't have to plug this in for the y prime. I could just plug the negative 4 in for it instead. That's actually kind of nice. That's really nice. I like that. That's how I would do it on my own anyway. I just didn't, I didn't know how it would be teaching wise. So, so then at negative 1, negative 3, y double prime is, all right, so in for y prime is going negative 4. And then this will be positive 1 because it's a negative 1. Okay, y minus 1, that's negative 4. Negative, so that's 1 squared. All right, so this is negative 4 minus positive 4, so that's negative 8.